Hi viewers, welcome to LMS Solution. Today we are going to see about variable step size P&O MPPT algorithm for solar PV system. Let's start with flowchart of variable step size P&O MPPT. This is a flowchart for that variable step size P&O MPPT algorithm. This algorithm we have to measure the following parameter: voltage and current of the PV panel, and then you have to measure previous instant voltage and current, and you have to calculate the current instant power and the previous instant power. And then initially you have to check with that LP. LP is nothing but power difference between current instant to previous instant, whether which is equal to 0 or not. So if it is equal to 0 means the PV panel is operated to maximum power point and level. Then no need to change anything here. Directly we return here. Suppose this condition is not true. So next you have to check whether the change in power is greater than 0 or not. If change in power is greater than 0, so next you have to check the change in voltage. The change in voltage is whether greater than 0 or not. If it is greater than 0, next you have to check the change in current. Change in current. So based upon change in current, if change in current is greater than 0, so you have to increment the duty cycle by using step 1, or else you have to increment the duty cycle by using step 2. Same if this condition is not true, then we need to check change in current whether it is greater than 0 or not. If change in current is greater than 0, then we need to decrease the duty cycle by the step 1, and then or else the condition is not true, then we need to decrease the step by that when duty cycle by step 2. The same way if change in power is not greater than 0, then once again we have to check the voltage level, change in voltage level, whether it is greater than 0 or not. If it is greater than 0, once again we have to check the change in current is greater than or equal to 0. If change in current is greater than 0, then we need to decrease the duty cycle by means of step 1, or else we need to decrease the duty cycle by the step 2. The same way this condition is not true, then once again you have to check the change in current based upon this current. If it is current this condition, we need to increment the duty cycle by step 1 or step 2. Here step 1, step 2 known as variable step size. So the step 1, step 2 is the parameter is going to be updated based upon following formula. So here you can see the step 1 and this is step 2. This is the formula for updating step 1, step 2 based upon change in power, change in voltage, and then current. And then this is the n dash a1, a2 are constant. Here you can see that a1 is less than 1 and less than a2. So this is a condition for updating step 1, step 2. Here the constants are n dash a1 and a2. A2 is always greater than a1. So a1 value should be less than 1. Then also another coefficient. Based upon this coefficient, step 1, step 2, and then moreover you can see that this value n dash a1, a2 is constant. The step 1, step 2 values depends upon three parameter, that means change in power, change in voltage, and current. So this value going to be changed according with this parameter. So this because of that, the value of step 1, step 2 always change according with this parameter. That's why it is improved variable steps is P&O algorithm. This step 1, step 2 value is goes to 0 when the PV power goes to maximum level. So this is the concept in the improved variable step size P&O algorithm. Here up how we are going to implement this algorithm in the MATLAB, we have to see here. This system is created for implementing that variable step size P&O MPPT algorithm. So this algorithm consists of that solar PV panel about 250 watts, and then this is load. Load is connected to the system by means of boost converter, and then the boost converter IGBT is operated by means of this variable steps. It receive different inputs. The inputs are PV voltage, current, and then that n dash value a1 and a2, and then maximum duty cycle value. Inside we written some code. Okay, this is the code for that variable step size P&O algorithm. Here you have to calculate step 1 and step 2, and then we have to check the condition, change in power, change in voltage, and change in current. Based upon that, we have to subtract and that and decrease the duty cycle by step 1 or step 2. The same way you can increment the duty cycle by step 1 and step 2. This is the code for that variable step size P&O algorithm. Based upon that flowchart, we created this code. Here you can see that this is a code for that calculating step 1, step. This code going to be executed if the condition, that means the n value is should be less than PD max divided by M. If this condition is not true, that means it's not execute this load. It would be maintain that duty cycle at the previous duty cycle. While if this condition is true, apply our variable steps explained earlier concept, or else it will be maintained at the previous duty cycle value. So this is a code for the variable steps explained algorithm. So next you have to check the system. Here I'm going to fix that irradiation equal to 1000 watts per meter square, and then I'm going to change the load every 0.3 seconds. Each load will be added at every 0.3 seconds, and then you have to check the performance of the system. That means how that voltage and current and power is changed according with the change in load condition. To check that one is a variation of PV current and converter current. This is a variation of PV voltage and the converter voltage. This is a variation of power and converter power. Here you can see that the PV power is almost maintained at the 250 watts, because so we are consider 250 watts panel or 1000 watts per meter square 25 degrees Celsius. The maximum power is around 250 watts. That 250 watts maintained in the PV panel with the changes in the load condition. Even though load is changes, the PV power maintained constant. So next you have to check the result with the change in irradiation condition. I'm going to change the irradiation. Here I'm going to change the irradiation for every 0.2 seconds, and then check the response of the P&O algorithm. Then when variable steps as P&O algorithm. Here you can see that this is a variation of PV current and converter current. This is a PV voltage and converter voltage. This is PV power and converter power. Here you can see that means every 0.2 seconds I am varying the irradiation from 1000 to 800, 600, 400, 200. Every 0.2 second the irradiation will be decreased by 200 watts per meter square. And also you can check the detail here. For 1000 watts per meter square, the maximum power is around 250. For 800 is around 200. For 600 is around 150. And for 400 is around 99. Here you can check the maximum power of this of the PV panel. So here I can see that the maximum power is around 250 per 1000 watt per meter square. For 800 watt per meter square, the maximum power is around 200 watts. For 600 is around 150 watts. For 400 is around 99. For 200 is around 50. For change in irradiation condition also, the maximum power extracted from the PV panel by using this variable steps as P&O algorithm, or else we can call this improved variable steps as P&O algorithm. That means we are going to adjust the duty cycle based upon two steps, step 1 and step 2. That step 1 and step 2 is calculated based upon this formula. So this is the working of this, the improved variable step size P&O algorithm for the solar PV system. Thanks for watching our videos. Kindly subscribe our channel and also click bell icon for notification of them. Thank you so much. Bye bye.